I am Niger, and I work at Prequel. We are an enterprise data sharing company based in New York City. And we've been using DuckDB in production since about version 0.41. And we've been really happy with using DuckDB, and it's kind of great to be here just meeting some of the people who've helped us with some of our issues on GitHub over the past couple of years. So kind of seeing people in person is a special experience. But really, to get into this, like, what is enterprise data sharing? So typically when we kind of bring this up with whether it's investors or prospects, the two big things people ask us is, how is this different than the data sharing offered by many popular data warehouses like Snowflake with their data share or Databricks with Delta sharing? Or we get asked a lot of questions about, okay, you're a data movement company, how are you different than Fivetran? Which is fair, which is very fair. So I think the best way to think about this is to really talk about what kind of data movement problem we solve. So specifically, we solve the problem of data sharing between SaaS platforms and their customers. And what that looks like in practice is that our customer is going to be a SaaS platform like Bookings.com. And I'm probably picking that one because I saw their name on a building next door, and that's the first thing that came to mind. So typically our customer is someone like Bookings.com, and the person we're going to transfer data to is their customer. That could be Marriott or Hilton or some other hotel brand. And the status quo today is that Bookings.com has some API, and Hilton or Marriott has a data engineering team who is either going to write a bunch of ETL code to scrape that API and bring that data into their data warehouse or data lake, or they're going to buy some tool that claims to have connectors to every single thing that Hilton wants, which might be Bookings.com, but could be all the other systems they use externally. And our core thesis as a company is that this is a pretty bad experience for everyone involved, right? If you are the person who's receiving the data, you're Hilton or Marriott, you don't want to be doing that work. Your best case scenario would be that you could press a button inside of Booking and get all the data directly in your system without having to do any of that work. And if you're Bookings.com, you don't really want to do the support work of trying to help people scrape your API. You don't want to have your API be scalable to this kind of large-scale scraping or bulk export. And when it comes to the actual experience of people using that data, there's all these different problems that can happen when you're trying to hit someone's API, right? The data is not necessarily normalized into a tabular format that's going to be useful for a downstream database or data warehouse. The data schema can change underneath you. And even if the system that you're using to move it can gracefully handle schema evolution, that system doesn't know when the schema is going to change. Only Bookings knows when they're going to change their schema, and only they know how that's going to break everything else downstream. And so what Prequel exists to do is to be a piece of infrastructure that any SaaS platform like Bookings.com can buy and integrate directly into their product so that they can offer data sharing as a first-class experience. And so that they can have a button inside of their application that says, export my data, and then the user can just pick, I'm using Redshift, I'm using Snowflake, I'm using a data lake on S3, I'm using a Postgres database. Like, this has nothing to do with analytics. I just want the data directly in my application database so I can do something else with it. We see that a lot. We have a lot of payments customers. And so the customer downstream wants to bring the payments data directly into their application Postgres and actually start using it live in their app. So where we really fit in is to facilitate communication between a SaaS platform and their user. And typically what we connect to is some kind of replica within the SaaS platform. That could be a read replica of something like MySQL or Postgres, but it also could be a Snowflake or Redshift instance that they are already mirroring data to. And then we will send that data to all the different customers who are signed up to use their data sharing feature. And so those systems could be also anything on the other side. Something as rudimentary as a Google Sheet, but also something more advanced like ClickHouse or Postgres or whatever else. And the way we really conceptualize this problem is as a transportation planning problem, because there's actually a lot of different ways we can decide to move data from one system to another, especially when those systems are different, right? We could choose to unload this data to Parquet and try to use some kind of copy command. We could use batch inserts of some kind. We can use inserts with CSV or JSON, depending on what those systems are. And so there's actually a lot of choices that we can make about how to move that data. And so how we kind of conceptualize the problem is we are trying to pick the shortest path to move the data that minimizes what it's going to cost everyone involved. So that could be egress cost, compute cost to us, but also while maximizing what we call data integrity, right? Because the worst thing we can do is either transfer the wrong data or to transfer that data incorrectly and lop off something important or transform it in a way that was incorrect. And so every time we move some piece of data, we call that a transfer, right? And for every transfer we do, we generate what is called a manifest. And so we've written a piece of software that we essentially call our planner, that it takes all these parameters about what we're trying to do. What is the source system we are reading from? What's the destination? What cloud are we in? Are we in AWS East 1? And are we moving towards GCP and US West 2, something like that? And can we come up with a list of steps to transfer that data that we can execute, right, that is going to fulfill that transportation planning system? And so this is actually where we use DuckDB the most, and we use it in two different ways. We use it in the planner both as figuring out what it is we want to optimize, like actually analyzing the data itself, but we also use it to do some of the transformations that I will talk about here. And really the focus of the discussion today will just be on how we deal with type integrity. And what that means specifically is we're moving data between very different data systems, right? It could be SQL Server and it could be BigQuery. And those systems have different levels of support for different types, right? That could be as simple as string encodings, right? SQL Server prefers Latin 1. A lot of other things are going to prefer UTF-8. And we need to make sure that when the data moves from source A to source B, that we have not permuted it in some way in which the person on the other side is going to interpret it differently. This is probably most important when it comes to decimals and floating point numbers, because as I said before, a lot of people use our platform to move payments data. And so if you've determined that, or if you've accidentally mapped some decimal value to a floating point value, and then someone does an aggregation on that in the downstream system, they may not get the same answer that you would get in the source system. And that becomes a big problem when you're doing something like budget reconciliation at the end of the month, right? When you're dealing with payments. And so type integrity is a difficult thing to maintain. And one of the things that we try to avoid is this, what I kind of call worst case data movement. So typically what our planner is trying to avoid is transferring data in this way, which you'll typically see. I mean, I'm kind of calling out Singer here, but Meltano works similarly. A lot of like open source ETL tools do a similar thing of, I'm going to give you something, a program I call a tap, that's going to read data by hitting some API. I'll have JSON. I'm going to pipe that JSON over to another program that we call a target, and it's going to write that data. And the bigger problems that come with this are it's not fast, right? Reading JSON out of an API and reserializing it is never going to be that fast. In the worst case, you're going one row at a time, potentially. If the API you're reading at doesn't have any kind of bulk export capability or doesn't allow for large page sizes. There's not transaction guarantees with this kind of thing, right? There's no guarantee that when I looked at one page, right, something previously didn't change while I was iterating it. And then, you know, we talk a lot within the field about types, right? Strong types, weak types. But I think where I've kind of netted out is that JSON is just poorly typed. And so you can see a bunch of solutions to this, like Mongo's binary JSON BSON or Postgres with JSON B, but almost nobody's API will give you binary JSON types out. And so we typically try to avoid hitting people's APIs, whether to read or to load data, right? And like a lot of the other talks that have already happened, we kind of consider Parquet to be the gold standard here, right? Because it's a binary format. We have structured types, and they're types that we can confirm from the file's metadata. We don't have to read every row to know what things are typed, right? And many of the systems that we are reading and writing to can produce and read Parquet files directly. So our ultimate happy path, like where we get the most bandwidth, is that we make the source system generate a bunch of Parquet files and materialize those to some object storage like S3. And the destination is compatible with that file already and can just load right from there. And if you get that nice happy path situation, you get hundreds of megabytes per second of performance because you're not really doing any transformation in the intermediary steps, right? We don't even have to really touch the data. But life is not that easy. So you may be familiar with XKCD, which is Randall Munroe's comic. And this is comic 927, where he talks about the issues with everyone trying to come up with a new standard. And so today, I'd like to propose an addendum to this, which I call 927B, which is that if a standard varies, it will vary infinitely. And so while I just said Parquet is a great solution and something that we kind of consider to be the gold standard, it is not perfect. And specifically when it comes to types, because if you give people the flexibility to do things with types, they will do whatever they want. And so even something that sounds simple, like a Boolean, where we're like, great, true or false, and Parquet even gives you a type for Booleans, is not so simple, as some data systems will say, I actually think a Boolean is a bit, and 0 is false and 1 is true. Or I think it's an untyped or an unsigned integer. Or for decimals, where this comes up a lot, is a decimal a string or an integer? And if you agree it's an integer, is it an int 64, an int 96, an int 128? Like, what really are these types? And so even though we have a much better type system here than we have in something like JSON, there is still variation. And the problem with this variation isn't just that it's different, it's that certain systems won't even accept the variance, right? And so there are some systems where if you try to give it a decimal as an integer, it'll reject that Parquet file. Or in the worst cases, the query engine is not that smart, it'll just null them out or zero them out. You'll get some really weird behaviors, right? And this gets even worse as you get into things like timestamps and complex types. And so we have this problem of part of what we need to optimize when we create that manifest is what transformations do we need to do to the data to ensure that when we put it in that destination system, the types are going to be interpreted in the way that we mean them to, right? And that this still happens relatively quickly. And so this is where DuckDB is super useful for us because it has a lot of built-in metadata features around Parquet files themselves. And these are built-in functions that are exposed via SQL that don't require also reading the entire file because Parquet has metadata in the headers and the footers of the file. You can do this very efficiently. You can do this off of a file that's on S3, right, without actually having to consume the entire file. And I'll show you a little bit about how we do that. I guess I'll start with something that's a little bit sacrilege, which is talking about ClickHouse at a DuckDB event. Let's see if I can open this. No, it opened in the wrong window.
Yes.
Sorry, give me 1 second. Technical difficulties.
You meant this?
Yeah, that's fine.
All right.
Yeah, that's fine. So what you're going to see on most other data warehouse products, you can go look at this in BigQuery or ClickHouse, as I've shown you here, is they're going to give you some table in the documentation of how they map some data type in their system with what is on, this is Avro, so this should be Parquet somewhere in here. Let's just refresh this and hope it jumps to the right place. But essentially, they will tell you how they map their internal types to whatever that type is in Parquet. And a lot of the times, you'll see that if you read all of these different documentation pages, these are not fully compatible. And this is where we use DuckDB itself. And so I'm going to open up 2 other tabs here. I've given myself some gist to work with, so I'm not going to do this live because that would be how it's. And let's see here. Great. So great. So the first thing I'll do is very, very simple, which is I will, let's see, will you do what I want you to do? No, I don't think it's the Zing. It's just not reading my query. Well, this is always the problem with live demoing, but no problem. We will adapt. Let's see if I can get back to the presentation.
Yes.
Should be behind it.
Yes.
Not going to remember that easily. So typically what we do is we use these Parquet metadata queries, right? So there's two big ones that we use. One is Parquet_metadata. This will tell you pretty much anything about a given Parquet file that you're looking at. It'll tell you how many row groups there are, how big those row groups are, how big the file is. You can compute pretty easily from that, right? How it's compressed. And that's broadly useful, but the one that we get the most usage out of is actually Parquet_schema. And what that will give you is every column in the Parquet file, its primitive type, its logical type, and some other metadata information about it. And what's really valuable about this function is that what our planning library can do is essentially every time we encounter a Parquet file from our source system, we can ask it about the schema of that file and determine, okay, this file has a decimal type that is represented by a byte array. But the source or the destination system we're going to put the data in requires some kind of integer back system. And so what we do from there is that our query planner essentially will enqueue the steps of saying, great, you're going to get this Parquet file, but then you're also going to convert this type with a DuckDB SQL query into a new Parquet file that has the decimal type represented as an integer. And largely what I would have shown you on the live demo is just me running the SQL queries to make that happen, right? And so this code runs directly within our workers. And so a big question that'll come up from how we're using this is, why would we use DuckDB to do this? So number one, we're a big Go shop, right? So we write a lot of Go, and the tooling around Parquet is immature, I would say, in kind of the Go ecosystem compared to Python or maybe Rust. So DuckDB gives us a lot of this stuff out of the box without us having to figure out how to put it together in Go. But it's not just that it's available to us pretty easily, it's also that we can not only look at this metadata, we can do the transformations necessary in order to convert the data to a better format for that our destination system will accept, right? And what's also really powerful about this Parquet support is that it works on S3. So if the source system generated those Parquet files and put them into an S3 bucket, we can do all this analysis without downloading any of those files. The other thing we love is that this stuff can be expressed in SQL, right? We deal with so many different systems that SQL is kind of becoming our lingua franca as a company. And so being able to say, I want to understand, does this Parquet file have any decimal types that are represented as a byte array? It's very easy to write a SQL query on top of the Parquet schema function that will tell you that. And then the last piece is it's actually a really big deal to us that this is embedded, because one of the things that we want to avoid from an architecture standpoint is having some kind of planning service. So our planner is just a library that's imported by the different workers we run in Kubernetes. And that means that every worker can generate its own manifest independently. It's not reliant on a singular or centralized service that we have to send all these requests to and say, here's a Parquet file, tell me what I can do with this. And that has benefits not only from kind of a system complexity standpoint, less services that we have to manage, but also from a security standpoint of these files don't have to leave the worker, and we're not sending customer data between different services, even within our own VPC, right? Everything stays within this worker that's ephemeral. And when that worker dies, all of our connections and any artifacts that we've generated from this data transfer process die with it. It's also easier for us to unit test because it's a library, not another service, so we're not dealing with necessary complex integration tests for something like that, right? And it's also very easy to run locally, which means if we're seeing something, in our production code, someone can run DuckDB locally on their machine, run the same queries, and see, what was it that our production code saw in that Parquet file or in that metadata. So I asked DALL-E, OpenAI's DALL-E, to essentially draw an image of how our system works, and this is what it came up with. The context of the humanoid dogs is that our naming service for a lot of our services has to do with shepherding dogs, because we shepherd data around. So these are, I think, a lot of border collies. I don't know what else is there, but this is what AI thinks our code does. So take that for what it is. But happy to answer any questions people might have.